Hey, this video is for the makeup session for 227-16. This is one of the sessions about tangent lines and linear approximations. There's all sorts of good stuff here. I really just want to highlight this part right here because this is the part a lot of students forget. And it has to do with when you have a concave down graph and you're doing a linear approximation. Notice that the tangent line is over the actual curve, whereas if you have concave up, the tangent line is actually under. So we'll see that worked out in a couple of examples. Okay, so you're going to do number one on your own. I'm going to work through two. It's just a basic tangent line. So you need a point, and generally you're given the x-coordinate of the point. Sometimes it's other information, but you're going to find the y-coordinate by actually just plugging in pi over 4 in for x. And so we need to use a little bit of trig here. This 2 times pi over 4, that is pi over 2. And if you think about this point right up here being 0, 1, the cosine of pi over 2 is going to be 0. So that's the y value of the point. So we can go ahead and knock off a few of these that we know it's not it. Now, in order to do the slope, we need to do the derivative. So the derivative of cosine 2x would be negative sine of 2x times 2. Don't forget the times 2, that's part of chain rule. And so in finding the slope, again, we're just going to plug in pi over 4 in for x. Again, that times 2, that gives us pi over 2. But this time, sine of pi over 2, that's the y value up here, that's going to be negative 1. So we have a slope of negative 2. We get C as our answer. Okay, 3 you're going to do on your own. Same with 4 and 5. Okay, let's look at 6 together. Excuse me. Alright, so in number 6, it says, first of all, we have a tangent line, and we're going to find an approximation. So this is the first approximation one we're doing. You're still just finding the point and the slope. And then you're going to use that information to write the tangent line. Then we'll get to the approximation. Now in this problem, they tell you that the x value is 3, and then this information up here gives you both the y value and the slope. So finding the equation of the line in this problem is actually the easiest part. The next part, it says, what are we approximating? A 0. Sometimes they're approximating like f of 1.1. This is a 0. That means that y is equal to 0. And you got to solve for x. So you just got to use all those good algebra skills. I'm thinking most students here are going to distribute through that 5. Add over the 15, and then divide by 5. Okay, and so that gives you 2.6. Okay, you're going to do 7 on your own. However, you can skip 8. It's not a bad problem. It's just we're not going to do this one. You're going to do 9 on your own. And then let's do 10 together. So it says the slope of the tangent line to this graph at the point where x equals 1 is. So all we're looking for is the slope, not even the whole equation. One thing about this is when we're taking derivative, you can use a log property here. It makes this so much easier. Use that log property that expands that into 2 logs. Now when you take derivative, this part's going to be easier. Derivative of natural log x is 1 over x. The derivative of natural log of y would be 1 over y. Since we're deriving implicitly, I'm going to have the dy over dx. That equals 1. So getting dy over dx by itself, you have the 1 minus 1 over x, and then divided by 1 over y. It might be important that you know what y equals, but here, because x is 1, you're going to get 1 minus 1 on the top. You're going to get 0. So I can figure that out without even knowing what y equals. Alright, if you had needed to know y, you would just plug 1 in for x here and here, solve for y. And I believe it ends up being e. Okay, you're going to do, actually we're going to do 11. This is a calculator problem, so I'm not going to show the calculator in this video, but I'll kind of explain the steps. So here we have a function. This is for what value of x, so I'm looking for x, not slope or y or anything. is the slope of the tangent line equal to 3? So basically, where is the derivative equal to 3? Okay, so what is the derivative? Now, since this is calculator, you could derive this in your calculator using the derive feature. You could also just use what we just learned in chapter 5, which is derivative of 2e to a power is the same thing times derivative of that power. Now, you can use the solve feature to solve that equation. You could also put the left side in y1, the right side in y2, and find the intersection. So however, that's not how you spell solve. However you end up doing this, and I'm going to suggest you use solve feature. I think that's the easiest thing if you have a TI-89. Just kind of go solve, and then comma x, and you end up getting 0.168. Now, if they wanted the whole tangent line, you may need to plug 0.168 back in for x. You're going to have to do something like that, sort of like similar on 12. Okay, so you write the whole tangent line. So you're going to do 12 and 13 on your own. All right, 14. We're going to work through, and this will be the last one we work together. So on 14, it has to do with implicit, and they give us dy over dx, which would be first derivative, and they give us second derivative. And then they say something about f of 1 equals 2. We call this the initial condition. This is how we find plus c, but in this problem, it's going to have another use. So first thing is just writing the equation of the tangent line at x equals 1. So let's think about our point. It's 1 comma what? This is where this initial condition is really helpful. F of 1 equals 2. So that tells us what the point is. So now all we got to do is find the slope. Now, derivative, I don't have to find it, they gave it to me. And since the derivative is xy cubed, I'm going to go 1 times 2 cubed, which would be 8. And so the tangent line, just using point slope, would be this. That's the answer to part A. Now for part B, it's saying use the tangent line to approximate f of 1.1. See, that's going in place of x. So that's what I'm going to do first. I'm going to rewrite my tangent line, but in place of x, I'm going to put in 1.1. Now you could simplify here if you wanted to. You don't really get extra points for doing that though. So I'm just going to get y by itself, and this y, I'm going to go ahead and make sure I write out like what I've actually found. I have found that f of 1.1 is about this. Now if you did simplify, you would end up getting 2.8. You don't have to do that though. This answer is perfectly fine. Okay, so that's the next part. Then we got to talk about, okay, well, is this approximation less than or greater than? This is where we have to know about concavity. If we look back up at the top, concavity has to do with second derivative. So let's evaluate the second derivative at our point, 1 comma 2. Okay, so we have our second derivative, d squared y over dx squared. This is going to be, remember we're plugging 2 in for y and 1 in for x. And you don't really have to evaluate this whole thing to know that this is definitely going to be positive. So because this is true, okay, then we know that f of x is concave up at 1 comma 2. Whoops, comma. All right, and if you've forgotten whether this is over or under, you don't have to guess. Just draw a picture. There's concave up. There's a line. Okay, if we were talking about approximating this value, this would be the actual. And then on the line, this would be the approximation. So I can see that the approximation is an under. Okay, so let's wrap this up. Therefore, f of, whoops, the approximation the approximation for f of 1.1 is less than the actual value of f of 1.1. And you don't really have to say because of this. We've shown all our work up here. It's for this reason. Okay, if you turn the page, you have 15. This is a table problem. You're going to do this one on your own, okay? And then on 16, I'm going to allow you to skip this whole problem. Parts A, B, C, all of that. Again, it's not a bad problem. It's just this packet's a little lengthy, so. And then 17 you're going to do on your own. Okay? All right.